Alright guys, Arduino Thermistor tutorial. We're going to use the thermistor, which is a temperature sensor. We're going to make use of a negative temperature coefficient thermistor in that when the temperature is going up, then the resistance is going to go down. At the end, we'll go through how to do the code in order to display it on our LCD display. There are a number of different thermistor tutorials out there. I've been working on my own, but why reinvent the wheel? There's a great YouTube video to follow after you've seen mine. So go to this link right here. Awesome video on how to get the thermistor to work with your Arduino. It'll give you a little bit more background on the voltage divider circuit. And then these two web pages from SensorSci and Amatherm are amazing resources for thermistors. They'll give you everything you need to know about thermistors and the different packages and housings and how they work and their applications. So go check these guys out. Pause the video for now. Go check these guys out now to figure out what a thermistor is and how it works, and then come back to me or check them out after you're done the video. Great resources. Okay, the parts that we're going to require. Well, the previous two videos were on the LCD display. Hopefully you've kept it hooked up. If not, hook it up again and then keep it hooked up. We're going to be doing a number of different sensors and using the values from the sensors and displaying them on our LCD display. So keep everything hooked up, grab another breadboard, and then we'll be using the separate breadboard to hook up our, in this case, our thermistor and our resistor voltage divider. Okay, so for that portion, we need the 10 kilo ohm potentiometer. We need a 330 ohm resistor or a 220 ohm resistor, the 16 by 2 LCD display, which you've already had soldered on all of your header pins, a bunch of jumper wires, and that's what you need to get to this guy hooked up. For this lab, we're going to be making use of the 10 kilo ohm thermistor and a 10 kilo ohm resistor. Each of the color codes are here, guys. Okay, if you haven't got a thermistor yet, then go online to Adafruit or any of your local suppliers. It is 2017, and it looks like the price that I paid for this guy is a whopping $6. So great deal. It gives you this thermistor here, the 10K thermistor, and in the same package, you'll also have the 10K resistor in order to create your voltage divider. Okay, what is a thermistor? Well, a thermistor is basically a ceramic unit that's packaged and it has a really tight tolerance and it provides you with an exact resistance for specific temperature values. So here I've got a graph showing how the resistance changes with degrees centigrade. So here you can see that it's a negative temperature coefficient in that as the temperature increases, the actual resistance value on the thermistor is going to decrease. So it's a negative temperature coefficient in that as the temperature goes up, the resistance goes down. The nominal value for this guy is a 10 kilo ohm thermistor, and we can see that at 10 kilo ohms, that value is coming in at a nominal value of 25 degrees Celsius. Any of these graphs or charts that I'm showing you, I've always provided with the link. Links are below, and they're also provided in the PDF of the PowerPoint, which is linked below in the comment section as well. Okay, what does this actually represent? Well, this represents the exact values that they're seeing in the table. So they'll take different resistance values at different temperature readings, and it doesn't matter which manufacturer you're going with, you're always going to have the same values. It's going to be really tight. In different manufacturers will basically provide you with the same values going through. So those values are available here in the output table. So this is a standard 10K thermistor output table. So Google this and it'll come up with it, or go to this link and you'll be able to reference this with me. So at that 25 degrees Celsius, that's where the 10K is coming in. It's a negative temperature coefficient. So as the temperature is increasing, so say we go from 25 to 28 degrees, then the values for the resistance is going to go down. So it goes from 10,000 to something roughly around 8,600. Okay, conversely, as the temperature decreases, so as we go from 25 down to 20 degrees, then the resistance is going to increase. Okay, so what we'll do is we'll revisit this chart as we're doing the lab, and we'll see whether we're getting like at around, depending on the temperature in the room, but around 20, 21 degrees, we should get a value that's between 11,000 and 12,000 for our ohmic value from our thermistor. Okay, if you haven't wired up your LCD display, then go back 2 videos in the playlist and I'll provide you with a tutorial on how to hook that guy up. The video right before this in the playlist simply was to show you how to put these characters on the display, the Arduino LCD wiring tutorial. Don't worry about that. You can watch that video, but I'm also going to show you how to embed that portion of the code into the temperature portion in order to display it on your LCD. Okay, the link for that guy is right here, or linked below. Okay, once you have that LCD display hooked up, then keep it hooked up because we're going to use it for a number of different labs going forwards. Okay, rather than reinvent the wheel, we're going to make use of the Adafruit tutorial. The best tutorials that I found for the Arduino are from Adafruit. If you go to this link right here, it's going to walk us through step by step on how we need to hook this up to our Arduino. It's going to provide us with the code that we need. They have great tutorials, accurate code. So it's not like there's going to be messed up code you're going to have to troubleshoot. They provide you with accurate code. You download it to your Arduino and everything works mint. Okay, prior to doing that, what we're going to do is we're going to open up our web browser. We're going to go to Tinkercad, and I'll just slowly walk you through how to set up the voltage divider circuit with your 10K ohm resistor and your 10K thermistor. So let's do that now. Well, I was going to go to tinkercad.com, but they didn't seem to have a thermistor as part of that simulation software. So we'll go with the fritzing diagram that's provided on the web page that we got off of the Adafruit site right here. So one thing to keep in mind is that if you go to hacktronics.com to this link, you'll find this diagram. It's a great diagram as to what we're actually doing. It's similar to having the potentiometer. So instead of having the potentiometer here, we'll have a variable resistor in that the 10K thermistor is our variable resistor. By changing the resistance here, we change the ratio between this resistor and our stable 10K resistor, and that provides us with a variable voltage out to our Arduino analog pin number 0. The one thing I want you to keep in mind is that this voltage right here on previous videos has been 5 volts. We've been using the 5 volt terminal. In order to do this lab, we're going to make use of the 3.3 volt supply. Okay, so the wiring is going to be a little bit different. We'll walk through that in 2 seconds, but just keep in mind that we were no longer using the 5 volt supply. We're going to use the 3.3. It's a more stable voltage, and we'll get more accurate readings for our temperature. Okay, so essentially we're putting 3.3 volts here. We're connecting the other side of our voltage divider to ground. Voltage divider meaning that we have a resistance here and a resistance here, and the ratio between those guys is going to provide us a 0 to, in this case, 3.3 volt. Easy now, 3.3 volt to our Arduino analog pin 0. Okay, let's walk through the wiring, guys. So the first thing we're going to do is we're going to connect our analog reference. So this terminal right here is our analog reference. And that is going to tie into, you can see that it ties right into the 3.3 volt terminal right here. So we're no longer using the 5 volts, we're using the 3.3 volts. Okay, we're tying that into our analog reference. In parallel with that, we're coming over here and we're feeding our voltage divider circuit. So here we have resistor number 1. So there's our stable resistor, right? So this diagram right here and the way that it's wired on this diagram are just backwards from each other. Here they have the resistor, 10K resistor first, and then the thermistor. And here they have the thermistor and then the 10K resistor. Doesn't matter which one comes first. It's a series circuit. It'll be exactly the same. So we're going to have the 3.3 volts coming over here to our 10K resistor. And then from the 10K resistor, we're going to go in series with our thermistor, our variable resistor. Okay, so you'll see that this line right here has both the one side of the 10K resistor and it has one pin from the thermistor connected together. Okay, so current is going to go through the resistor, through this thermistor, come back to this terminal right here, and we came from the positive, so we've got to go back to the ground. So this rung right here is going to come over, and it's going to reference the ground terminal on the Arduino. Okay, so get that guy hooked up, and hook up your display as as you've done on the previous video, and let's jump right into the code. And we'll basically copy and paste the code into Arduino, and we'll download it to the Arduino and see how it works. Okay, so just go back 2 slides and then click on this link here. And that will open up the Adafruit page where it gives us our tutorial. Again, if you're not clear on what I've done in the video, then slowly read through what they've prescribed here, and they'll show you exactly what to do in order to get this hooked up. So here you can see on theirs they have the positive to the resistor, the 10K resistor. From there, they're going in series with the thermistor right here. So through the resistor, back to here, back to the negative right here, and this negative is tying into the ground, and this positive right here is connecting into the 3.3 volts. Okay, if we scroll down here, then what we need next is we need our code. So there's an explanation here as to how you can provide yourself with the resistance through that voltage divider equation. So have a read through that. The initial file right here we're going to leave because it uses the 5 volt reading. So what we're going to do is we're going to scroll down here, and it says better readings. It says when doing analog readings, especially with a noisy board like the Arduino, we suggest 2 tricks to improve the results. One is to use a 3.3 voltage pin as an analog reference, and the other is to take a bunch of readings in a row and then average them. Okay, the first trick relies on the fact that the 5 volt power supply comes straight from your computer's USB and does a lot of stuff on the Arduino, and it's almost always much noisier than the 3.3 line, which goes through a secondary filter and regulator stage. Exclamation mark. It's easy to use. Simply connect the 3.3 to the analog reference, which we mentioned before, and use that as the VCC voltage. The VCC just means the supply voltage. So rather than 5 volts, we're using 3.3 volts. Because our calculations don't include the VCC, you don't have to change your equation. You do have to set the analog reference, and it's a single line of code, which I'll show you. Taking multiple measurements to average out the results will help get slightly better results as well, since you may have noise fluctuations. They're going to take 5 different samples in this code. Rewire as shown, and the 10K resistor is still connected to the higher voltage. Thermistor is to ground. Okay, so let's scroll down, and then on this page they also have the code. So we can download the file here, or we can simply go along and grab the actual code here. So we're going to copy here, and I'm going to open up a new Arduino program here. So we'll just go File and New. Okay, let's minimize this bad boy. Let's open this guy up. Looks good. Okay, so let's move this over a touch so we can see everything that's going on here. Beautiful. And so let's get rid of this guy. Let's delete, and let's paste this guy in there. Okay, so we're just pasting in the code directly from the Adafruit site. If we scroll up here, everything looks good. Okay, and now what we're going to do is we're going to download this to the Arduino. Okay, so this initial portion that we've just downloaded is not going to put anything onto the screen because we haven't. There's nothing in the code. So if we take a look here, there's nothing here where we've put in the LCD screen. But let's see what they've done here. They've taken the temperature and they've done it to a serial print. And above at the beginning here, we can see that we've started the serial begin here. So if we go to the serial monitor, we should be able to see some values here. Beautiful. Okay, so here you can see that this program that we've just downloaded is going to provide us with the analog reading from the thermistor. It's going to give us the thermistor resistance that corresponds to that, and the temperature, right? And the ambient temperature in the room is fairly accurate at 22. My wife's had the heat cranked for the day. So well, we have 22 degrees here, and if I put the auto scroll back on, then you can see that those values are consistently coming in here. Okay, so again, we have the analog reading here, right? So we have the analog reading. Remember, that's a 0 to 1023 value. the thermistor resistance that corresponds to that. And from the chart, 11,321 should be very close to 22 degrees Celsius. Okay, so let's slowly walk through the code and see what they've got here. So the beginning part here, they've got some descriptions here, which analog pin to connect to. So they're defining this global variable thermistor pin on A0, which we've done before. The resistance at 25 degrees Celsius. So we have to have the nominal resistance for the thermistor. And remember that at 25 degrees, it's a 10K resistor or thermistor, right? So they've defined that global variable. Then below, the temperature for the nominal resistance, which is 25 degrees. So they put the temperature nominal at 25. And how many samples to take, an average. More takes longer, but more is smooth. So they've defined the number of samples as 5. So they're going to take 5 separate samples and then punch out a value. The beta coefficient for the thermistor is usually between 3,000 and 4,000. So they've provided a value of 3,950. So that punches into those equations that we saw earlier. And the value of the other resistor. Well, the series resistor that's in series with the thermistor is a 10K resistor. Okay. The next thing they're doing is they're putting in a U integer value here and the number of the samples, and then they're referencing this number of samples, and that value right here is equal to 5. Okay, so those are all the initial setups there. Then they start in on the void setup. In the void setup, they're simply doing 2 things. They're doing the serial begin so that we can use a serial monitor, and they're using a 9600 baud. And remember that the analog reference is no longer 5 volts. So that single line of code where they're saying that instead of being 5 volts, we're going to be the 3.3 volts. This line does that right here. So the analog reference is referencing an external voltage. That external voltage is now 3.3 volts based on the wiring that we completed just prior. Okay, that's the void setup. That's done once and then it's done. Okay, below we have the void loop. In the void loop, we have a U integer value where they've created this like variable here just within the void loop of I, and they've created a float. Okay, so for the float, they're going to take some decimal places, and that value is going to be based off of the average of the 5 readings. Okay, below it says take n samples in a row with a slight delay. Okay, so what they're doing here is they're saying it's going to start at 0. As long as it's less than the number of samples is 5, then create that value and then do an analog read on the thermistor pin. And the thermistor pin, again, from above was stated that it was going to be A0. Then a slight delay. Okay, then below, average all the samples out. So here they're doing an average of the samples, and the average is equal to the number of samples here, and then we're going to see that value below. Okay, the serial print. So this is the value that we're seeing on the actual serial monitor. So let's scroll down here. So here we called for the serial monitor above at 9600 baud, and here's the serial print, and they're saying in quotations the average analog reading. And if we open up the serial monitor, then we can see right here, average analog reading, and then a space, right? So average analog reading, and then a space, and then the value is going to come in. How does that value come in? Well, right here they said serial print line, so on the next line, put in the average, and the average value is equal to this value right here. Okay, so that value is punched in, so we have 540, right? Remember that value is between the value of 0 and 1023. Okay, and then what else do we have? Convert the value to resistance. So we have a number of things going on here to change that value to the resistance, right? Then it says the thermistor resistance and a space, and again they're putting the average value. So change the average value here, punched it in here, and thermistor resistance with a space, and then we've got 11,464.54. Remember that these values are a float, so that's why we're getting a decimal place there. Okay, then below here, we're creating another float with a Steinhardt equation here. So this value right here is going to change that resistance value and convert it into degrees Celsius. Okay, then below we have finally the serial print. They're saying the temperature and then a space. So we're seeing that here, temperature and then a space. And then the Steinhardt value, right? So the Steinhardt value changes throughout these equations here and is finally punched out here as this value right here, 22.23. And then to put in the degrees Celsius, they then put serial print line, right? So on the next line there, they put degrees Celsius there. I'm not sure if the print line is needed there because it's right beside. Okay, then they're putting in a delay of a second before it goes right back up to the top and then provides us with that value. So we'll see that the values just come in every second and they're slowly changing based on the ambient temperature around that thermistor. Okay, so hopefully everything's making sense so far, and I've been able to properly explain their code so far. And we've been able to see everything on the serial monitor, but it would be even cooler to be able to see it on our liquid crystal display. If you're interested in looking at a PDF where each of these additional portions of code are highlighted, that link is below, so you can go link to that, open that up, and have a look at that as we go through. But the first thing we're going to drop in there is obviously the liquid crystal display library. So we're going to do this line right here. So right before the void setup here, we're going to put number side include, and we're going to include the liquid crystal.h. Okay, that's going to bring up the liquid crystal library. Then we're going to put liquid crystal. We're going to create a global variable here, LCD. I just determined to do it in lowercase. And then remember that these pins right here correspond to the way that we've hooked up our LCD. So 12, 11, 5, 4, 3, and 2 correspond to the terminals that are required within our coding. Okay, so we have our liquid crystal display library, and now we've determined which terminals that we're actually going to make use of. Okay, once you've done that, then go down to the void setup. Okay, remember they already had this, the serial begin, and they had the analog reference, and they were referencing an external voltage of 3.3 volts. The only thing that we need to do in our void setup is we need to begin the LCD, and we need to tell it that we have a 16 by 2 liquid crystal display. Okay, once you have that, then, and again, if I'm going a little bit too fast, then just pause the video at each point. But I'll try to pause my voice so you can keep up with me. So first thing we're doing is we're including the liquid crystal.h. That's the library. Then we're setting up our pins, and then we put in the LCD begin. Okay, below in the void loop, let's see the additional things that we have here. Okay, so we're going to scroll down. Everything is exactly the same here. Okay, so they're doing the serial print there. All right, so everything's going to the serial print. That's available on the serial monitor, but we want it on our LCD. So the only additional things that we need there would be to first to set the cursor. So for our initial thing that we're going to put on there, we're going to set the cursor to 0, 0. So first column, first row. Remember that everything starts at 0. Okay. Then what we're going to do is we're going to print this value right here. So you can see that it's in quotations here. So this is not a value that's available up here. It's just simply going to print thermistor. And then, is there a space there? I've just put in thermistor value. Okay. Then below, I put in LCD print. So I haven't done a print line. I'm just doing the print. And then now I'm grabbing this value, this average value, which is available up here, right? There's our average value right here. So it says print thermistor, and then right beside that, put in the average value. Okay, then we're going to put in a small delay here before we set the cursor again. So we're going to do lcd.setCursor. Okay, remember that the C is a capital C there. And we're then going to the next row and the first column. Okay, next thing we're going to do is we're going to put in temp. Remember that we're limited to 16 places there on that row. So if you put temperature, then you're probably going to run out of space there. So just put temp and then put a space there. And the value that's going to go beside this temp is the Steinhardt value. And again, the Steinhardt value is referencing this bad boy right here. Okay, so it's going to physically put in temp, then a space, and then this value, which will be changing based on the equations that are above. Okay, we want to put in the fact that it's Celsius, so I haven't had any spaces here after the Steinhardt value, so I'm going to put a space here, and then I'm going to put degrees C. If you want, you can put degrees C like this, but I would just put the C just to keep it concise. Okay, then again, I'm putting a delay in there before it loops up to the top there. I'm going to actually increase this delay to 1000 just because I can notice on my camera that it's blinking a little bit with the camera's display rate. So I don't want to screw that up. So when you're actually viewing the thing. So we'll put in 1000. So let's upload that to our Arduino. And then let's see what comes up on the display there. Beautiful. There we go. So it's continuously cycling through. It's sampling the value from the thermistor, providing the thermistor resistance value, and then it's providing us with the temperature. Right? So there's a half-second delay before it cycles up to the top, but we can't see that with our eyes. Okay? The way that this is set up, which I haven't gone through yet, is the fact that you can see here that I have my 3.3 volts coming in here to my 10K resistor. I've then connected in the thermistor here. There's my actual thermistor that's taking the temperature reading. And then from there, this green wire right here is referencing my ground. Okay, if you go back to that chart and we look at a value of 11,000, guaranteed it's going to be very close to 22 degrees on that chart from the 10K resistor or 10K thermistor. Now, this one has a negative temperature coefficient. So see if you can figure out the answer before I do this. I'm going to place my fingers onto the actual thermistor, which is going to heat it up. And what do you think is going to happen to the resistance value? Is it going to go up or is it going to go down? Okay, so I'm now grabbing onto the thermistor. You can see that the temperature is now increasing. But the resistance value is going down. Remember, it's an NTC thermistor, right? So as the temperature goes up, then that resistance value goes down. Okay, and it's continuing to climb here. If I let go of it, then it will slowly, remember this, like how fast we're getting the values on the screen, easy now, is related to two things. It's based off of how fast this value is changing, right, on the actual thermistor. It's also based on the sampling rate that we have within our code. Okay, but you can see that, again, the temperature in the room is, let me just pan out here. So I'll bring in a temperature gauge here and we'll see how accurate this actually is. Let's drop this down a touch. Let me put my temperature gauge right here and we'll see how accurate this guy actually is. There we go, so you can see it. Let me just get this so you can see it properly. A little bit of a glare there. Not sure if you can make it out. So in the room right now, it's saying that it is 22.3 degrees. And we'll see whether we see that value on the display here. So it takes a little bit of time to go back to reference the value in the room. Let me pause here and we'll see whether we get an accurate value in a couple of seconds. Okay, so that is mint. I mean, look at that. We got 22.3 degrees, and on my digital thermometer there, we got 22.5. So it's acting like mint, man. Like, look at the accuracy there, right? There, 22.46, right? We're getting even more accurate, 22.55, right? So that's mint. These two values, right? This guy right here that we've just created with a bunch of code, and this value right here, right? Which is a standard, calibrated value. They're pretty close, man. That's awesome. Okay, if we take a look at that value, it says 11,224. Let's open up this, guys. So let's go to this bad boy right here, 11,224. Well, that would be right between these two values right here, right? And so the value that we're saying is like around 22.4 degrees, right? So that's where you can see that the resistance value is matching with the actual degrees Celsius that's available from this chart. Okay, so what I want you to do now is hold on to your thermistor, increase the temperature there, and see whether the value for the resistance matches with the output table, and whether you're getting an accurate reading between that. And so hold on to your meat thermometer and hold on to the thermistor, and see whether the two temperatures are matching there. So finally, just to demonstrate that, I'm going to grab the meat thermometer here, and you'll see that the temperature is starting to increase. I'll grab the thermistor here, and you'll see that the values are different, right? They're just off by a touch. So remember that, like, if I kept holding on to these for a while and then finally the temperature actually settled out, then the two values will be probably deadly accurate once again. But remember, see, there we go. We're getting closer, right? 31.6, 31.55, right? So remember that the sampling in the code will determine how quickly that degrees Celsius comes up on the display. But this is pretty cool, man. We've been able to, within, like, I think this is our 12th video here, we've been able to now set up the Arduino, right? And now start to get some live readings from an actual sensor that we see out in the field. So we've done the thermistor. Next videos coming up in the playlist, we'll go over the thermocouple and the RTD, which are different temperature sensors, which act on different principles. But again, the coding should be, fairly similar in the way that we display that value. Getting into the actual equations, that's a rabbit hole with the Steinhardt equation and everything. If you'd like to go deeper into thermistors and to why that equation is actually used, then follow the links that I've provided. Go to the Wikipedia page on thermistors, and it'll provide you everything you need. Hopefully you've enjoyed this video. Hopefully I've been clear and concise in the instructions, guys. If you have any constructive criticism, then leave them in the comments below. Thanks for watching, guys. We'll see you on the next video.